Course 3, Lesson 118. We are looking at some trigonometric ratios called sine, cosine, and tangent. We've looked at actually the different ratios that we're going to do today in a previous lesson based on the opposite and adjacent sides along with the hypotenuse of our triangles. So first of all, let's just talk about these trig ratios. Sine comes from having the ratio in our triangle of the opposite leg over the hypotenuse. Now remember, when we look at these trig ratios, we base them on a particular angle. So let's say we have angle A right here. Well, the sine of this angle A would be the opposite, which is right here. Okay, it's across from it, and then over the hypotenuse. So whatever those lengths are, to find sine, I would be doing opposite over hypotenuse. Cosine is using the adjacent, which is close here, adjacent, it's right next to it, over the hypotenuse. And then tangent is the ratio of the opposite leg over the adjacent leg. A lot of times you'll hear different people remember these in many different ways, but probably the most common is using these terms so, ca, and toa. The reason that we use those is to remember that sine, okay, starting with that S, is the opposite over the hypotenuse, so S-O-H, so. Cosine is C-A-H, so cosine is adjacent over hypotenuse, ca, and then toa is tangent, is opposite over adjacent. So this is a way to remember them if you need a way to remember these trig ratios. So let's go ahead and put them into practice. So we want to find the sine, cosine, and tangent of this angle A right here. So if I want to find the sine, I'm going to be doing opposite over the hypotenuse. So if I have this angle A, opposite of it is the side length of 6, and the hypotenuse is 10. So we would say the sine of this angle is 3/5 or 0.6. Cosine is then the adjacent over the hypotenuse, which the adjacent from angle A is right here of 8 over the hypotenuse of 10. So we could say this is 4/5 or 0.8. Lastly, the tangent is our opposite over adjacent. So opposite is 6, adjacent is 8. So we can say this is 3/4 or 0.75. So we have all of these different ratios in respect to angle A. So how about if I don't know what the side lengths are, but know that angle R is 30 degrees? Well, for this to make sense, we know that angle T is a right angle. And knowing all of this, if this is 30 and 90, we know that what's left for angle S is 60. Well, this is a 30, 60, 90 right triangle, which means it has a ratio that we actually already know, side lengths that we can assume. Well, based on the pattern that we've learned in a previous lesson, a 30, 60, 90 right triangle has a ratio of 1 to √3 to 2, going from smallest leg to longest leg or hypotenuse, which means the smallest leg is across from the smallest angle, so it would be right here. The middle leg is across from the middle angle, so right here is our √3, and across from the 90-degree angle or our hypotenuse is 2. So from this we can now find the sine, cosine, and tangent of this triangle. So sine, okay, we abbreviate it with SIN. We do opposite of that 30 degrees, okay, because R is the one that we want. So opposite of 30 degrees is 1 over the hypotenuse of 2. So we say that's 0.5. Cosine is adjacent, so √3 over the hypotenuse of 2. And we can use a calculator to figure out what that is as a decimal. So let's do that really quick. √3 divided by 2. So I would say the square root of 3, and then go out of this to divide it by 2. Okay, so √3 divided by 2 is 0.866. So let's go ahead and put that down. 0.866. And then lastly, our tangent. This comes from the opposite leg of r, so 1, over the adjacent leg of root 3. Now we could leave it like this, or we can use our skills that we have learned to rationalize the denominator, which of course I would recommend. By multiplying by root 3 over root 3 gives us the square root of 3 over 3. And we can plug this into our calculator as well and say the square root of 3 divided by 3. So root 3 divided by 3 gives us 0.577. All right, 0.577. Now this is an easy one because we know what the ratio is for that 30, 60, 90 right triangle. But we also need some other methods in order to figure out what this is if that pattern is not actually exactly 30, 60, 90 or 45, 45, 90. So what we can actually do is use our calculator, and our calculator knows what the sine of 30 degrees is because Trig works with those degree measurements as well. So let's see if we get the same amount. So sine, before we got 0.5. So let's use our calculator here and say, all right, well, what is the sine of 30 degrees? And we get 0.5. Well, let's try it again. What is the cosine of 30 degrees? We should get this root 3 over 2 like we did before. Let's see, cosine of 30 degrees is 0.866. And lastly, tangent of 30 degrees should give us this 0.577. So tangent of 30 is 0.577. So if we don't know what the side lengths are, calculators actually can use the degree measurements to find the ratio anyways. This can also help us find missing side length if we know one of the other side lengths. So we can use our calculator to calculate with degree measurements as well. Your calculator might look slightly different as far as how it works, but it should have, if it's a scientific calculator, it should have those functions. So let's try it for a different amount like 35. Let's find sine and cosine of angle A. Okay, so if I want this, then I'm going to be doing sine of 35 degrees, and this should be angle A, B, C here. I'm not sure why it was messed up, but that's okay. Sine of 35 degrees and cosine of 35 degrees. All right, let's see what our calculator says for this. So it says the sine of 35 degrees is 0.574, rounding, and cosine of 35 degrees is 0.819. Now I could find the other angle here pretty easily by saying, well, if that's 35 degrees, then this must be 55. So I could find the sine and cosine and tangent of angle B by doing sine of 55 and cosine of 55 and tangent of 55. All of this while not knowing what those actual side lengths are, I can find the ratios of sine, cosine, and tangent. All right, so let's actually use these with two examples, and then this video will be finished out, to actually find some lengths that are hard to measure, because Trig actually uses that a lot. Trig ratios are here to help us find measurements that we cannot actually measure, like the height of a tree. So with this tree, if I have this respect to this 22 degrees, and I have that my adjacent side here is 100 feet, and I want to know the opposite side, well, opposite and adjacent sides are used in tangent. So I would use the tangent of 22 to say, well, the tangent of 22 is this side x over my 100 feet. So opposite side x, which we don't know, over 100 feet. Well, if I figure out what the tangent of 22 is, then I can figure out what x is. So let's go ahead and figure out what is the tangent of 22. And let's try that out. Tangent of 22 degrees is 0.404. All right, so if the tangent of 22 is 0.404 and we have x over 100, to get that x, I'm going to multiply by 100 on each side, which means that the height of the tree is 40.4 feet. Okay. All right, so in this, we would find that height of the tree by solving for this. And let's see. I feel like I have done something incorrectly. Let me just check my work really quick. So after checking my work, I do see that we have done this correctly, and we get a height of 40.4 feet as the height of that tree, using that trig ratio and then solving for our variable. Okay, and let's just do it one more time with this one, and let's draw a picture. So it says the height of the kite is the side opposite the degree angle of 42 degrees. So we have this triangle here, 42 degrees, and we have this kite up above, and we're trying to find this side length here to find how high is the kite in the air. And we also know that the side that is adjacent is 100 feet. So if I'm using an opposite side and an adjacent side, I should be using tangent. So tangent of 42 degrees is that opposite side of x over 100 feet. So let's figure out what is tangent of 42. So let's just go ahead and edit this one. And let's say we have 42 degrees instead, and we get 0.9004. I'm going to keep that 4 in there just to keep it as exact as we can. So 0.9004 equals x over 100. And since we've divided x by 100, I'm going to multiply by 100 on each side in order to solve this. And I get 90.04 feet equals the height of that kite. So we can use our trig ratios in order to solve problems where we can find sides of this triangle that we might not know. Okay, so we use trig ratios for a lot of different things in math and in our world, and this is just a brief introduction to that. I hope this video helps with your homework and for studying.